So very welcome everyone to this session about model-based system engineering. My name is Johannes, I'm CTO at Technia, and I'm here today together with my good colleague Achim from our German team. Hi Achim.
Yeah, my name is Achim Simon and I'm responsible for customer value in the DACH region.
Excellent. Yeah. And today we have a very interesting topic that you would like to share with the audience, right, Achim?
Yes, you're right. Then I will start. So before we start, I have some questions, Johannes. So in the picture, you can see that cars are becoming more and more complex systems and not only a capped system, so they are interacting with other systems. And if you can imagine, if I am a supplier or a startup company, I want to develop more than a product. I want to develop functions and services. How can I manage the complexity for such kind of products?
Yeah, I think it's a very valid question, and of course the big OEMs, they have already been working on this for years. But I think even as a supplier of any of these quite complex and advanced subsystems that today consists of both electronics, a lot of software, a lot of cabling. You can see some of the metrics on this slide, and it's growing by every year. I'm quite confident that even suppliers need to really look into the methodologies that are there from a systems engineering point of view. And I think you will introduce us a bit to some of the key methodologies and ideas behind, and then we'll get back and show more in real life what this could look like in a system like 3D Experience. So take it away, Achim.
Yeah, thank you. Then I will start. So if we look to the tradition of systems engineering, it's not a new topic. So aerospace and defense are processing these process since many years. What you can see in that old-fashioned picture, let's say, you will have a concept phase on the left, and you're starting with a systems architecture design, and at the end you are going to do your modeling of the solution. But if you see in an increasing branch of the V, that you start your verification with the units, and later on you do the integration tests. And mainly it was done in a physical prototype. And you can see validation will be done at the end. That indicates for me that the process or the projects are mainly waterfall projects where you deliver a solution at the end and you have the verification. It might be that each domain, so electronics, software development, might have their own V models. So that makes it much more complex, and in the past, or maybe in the present right now as well, all contents was managed in documents, and that makes it really complex. So the question is, what is needed to bring systems engineering in a digital world? First, you have to know it's a holistic approach. So you don't just look at the product itself. You see that the system is a combination of interacting systems. You can say system in a system, and interaction with stakeholders. You have to understand the mission, the services, and the functions of your product. So function can be expanded trunk space. The solution can be a trailer or roof rack. And services might be new functions after sales. These can be services delivered by the producer. How is the way to come from traditional way of working to the new digital way? So the buzzword is breaking the silos. So what we recognize that our customers is that the domains or divisions are working isolated from each other, and the goal is to bring all these disciplines together in one common data model. So mission, service, functions, and at least the components, the design are combined in a common data model. What you have to respect is these three angles, let's say. So process is the way of working together. The method is how you describe the model, so how you model the system. And the tools are hopefully integrated that you will be able to have all information available on one platform. So if we reflect these to the traditional V model, you can see that requirements and system architecture is built in a decreasing branch of the V model. But what you can see is that the different disciplines are linked to the same requirements. They are connected to the same system architecture. And what you can see as well is that integration is possible not in an increasing branch, it's also possible in a decreasing branch, and you have the chance to do simulation of concepts. That shows that interfaces are becoming important as well. So you have different simulation tools or different modeling tools already in your company, and it's easy to implement them. So I want to name two of these. One is SysML to model a system architecture. Another point is FMI. It's mainly for the system simulation, function mockup interface, to do validation and tests. And if you see that in an increasing branch, it might be possible that you can use your system, your entire system model as a kind of a digital twin. If you do a simulation from a digital twin to a physical controller, or otherwise versa, you have a virtual controller and you want to connect it to a physical mockup in a hardware in loop environment. What are the benefits of model-based systems engineering is that you will be able to model the system in a digital environment. So you don't manage contents of documents or manage documents, and you have to open the document to get the right information. So you are running verification and validation in a virtual world that helps you to save physical prototypes. So you have the chance to shorten the development time by parallelization. That also helps you to, or allows you to have more loops by the development. That helps you to get a better product. And it also allows you to do changes in a later development process. That means by the combination or the links from requirements to solutions, you will be able to have the right information for the right decisions, or you get the impacts by changing some requirements. At the end, you have to control the complexity of such new systems.
So, as Achim has excellently explained, it's a lot of disciplines that needs to be mastered to manage system engineering properly. And to support that, you need a set of tools and a platform that ties all of this information together. So what we would like to show you today is how this can be done on the 3D Experience platform, a system that is web-based and bring this information out to the general audience in the company, not only to the specialists and system engineers across different teams. So, but let's start with some basics. So, like Achim has already explained, to move from traditional ways of working using mainly parts, 3D models, documents to describe systems and products. To be able to go beyond that and start working model-based, you need some additional ways to describe and manage the information. So in the 3D Experience platform, there is a foundation, a data model that supports model-based system engineering and the model-based way of working. And to explain that, starting from left, the first part is the requirements dimension, where all the detailed requirements describing a product are captured and documented as live data in a database, not as static documents, which means that this information can easily be kept up to date, and any changes during development will easily be reflected. The second dimension is the functional one, and this is a functional breakdown of the product, outlining all the main functions that the product is going to perform according to the requirements that has already been specified. The next step, when things are starting to materialize, is the logical breakdown, and this is where you start to decompose your product, in this case a car, into the different subsystems and identify the modules that are going to be there. And these, of course, have to be in compliance with the functions that has been defined in the previous step and with the overall requirements. And then finally, you will arrive at the physical design. And by physical in this context, we mean not only the mechanical artifacts like the parts and the mechanical design, but also any electronics and software that goes into the product. So the physical part is the lowest, is the bottom of the V model, where all the concepts, functions are converted into an actual implementation. So from this physical definition of the product, you are also able to extract bill of material information and any other information that is needed for downstream activities, so that you will also eventually have a manufacturing bill of material according to how the product is going to be made. So this is the technical foundation for doing system engineering in 3D Experience. And the big advantage of having all of this in the one and the same platform is also that you can very easily maintain the traceability. And like I said from the beginning, if there are changes, you can very easily understand the impact. If a requirement is changing, which functions, which physical parts of the product is affected if a change happens. So by that, I will switch to the demonstration part and show how this is actually working in the 3D Experience platform. Okay, so now we are logged into the 3D Experience platform as an ordinary user. So just again to emphasize that this is not only for the system engineering experts and the domain subject matter experts from the different domains. This is a tool that can be used by anyone that participates in the product development process. So in this small scenario that we're going to show today, let's imagine that we are a startup company developing a new electrical vehicle, all the way from concept to prototype and actual manufacturing. We are, since the topic of today is the model-based system engineering, we are mainly going to focus on the vehicle architecture and the system design. So let's move on to the system engineering view of the product. What we see here in the middle is the high-level view of the vehicle. This is the main systems that the vehicle is composed of. The subsystem that we're going to use as an example today is the emergency braking system, which we can see here at the bottom. So by opening that subsystem, I will get kind of half of the V shown on the screen. So like Achim explained, we have the V model that starts with requirements, ends up with, at the bottom, with the actual technical solution. From this view, it is very easy then to access all the details about the different information that is needed to describe the system. So starting from the top, these are the requirements. So if I click this link, I will get directly into the requirements, the detailed requirements. So from here, I can scroll through and review all of the requirements that have been raised against this subsystem of the vehicle. And then, of course, in the background, there are requirements engineers working on refining and detailing those requirements. But this is an easy way for me as a system engineer to view the requirements and get an easy overview of the status. These requirements will then lead to the functional design of the system. So by accessing the functional architecture, you know, in the functional dimension of the system, the system definition, it will first show me a high-level view of the entire vehicle with all systems and surroundings. But to understand how the different functions are defined, I can then zoom in and dive into the different main subsystems. And in this case, we are interested in the advanced driver assistance systems. So I can continue to zoom in, and the system will then gradually show me all the details of the subsystems that are contained again inside of this section of the systems. And the specific system that we are interested in today is the autonomous emergency braking system. So if I zoom into that one, I will get access to the detailed definition of all the functions that this system is supposed to perform. So from that perspective, you can drill down into to all levels of the system architecture. Then the next level is when things start to materialize, and you will start to define on a conceptual level what the different subsystems are supposed to do. So you can then dive into the functional interactions, see the block diagrams, what are the actions that are going to be performed. You can look at further details like the state machine. So these are quite advanced and detailed models of the behavior of the system. And furthermore, you can look at information like block diagrams, and also the environment and the main use cases that the system is going to perform. So from here, any stakeholder can easily dive in and get a good understanding of the different behaviors of the system at an early stage. Leading from this, you have the actual implementation, and this is like Achim showed you before, information that could come from other systems like MATLAB, Simulink, and here you can also have the possibility to deep dive on how the different algorithms and functions are designed. So here you can open up, zooming in, and open up the logical circuits and the definitions of the business logic and behaviors that are defined inside this control system. And then at the very bottom of the V model, you get down to the actual code that is going to be where the algorithms are actually implemented. So by zooming in on this one, you are able to actually review the actual source code all the way down to bits and pieces. The last thing I would like to show you from this view is that you can also, to ensure that all requirements are satisfied, that the functions have been properly converted into systems and functionality, you can turn on the traceability view. And this will give you a very visual overview and status of the fulfillment of each level of the V model. So that in this view, for instance, you can easily see that 90% of the requirements have been successfully converted into functions and so on. So it's also a very powerful tool to keep track of the progress of the system development. So that's what we plan to show you today. Of course, there is also a second part of the V model that we didn't touch on today, but that's a topic for another session in the area of test and verification management. So to conclude, model-based system engineering is a modern way of working that can be supported with best-in-class tools like 3D Experience. Big advantage of that is that you can provide and support the same way of working across all development disciplines, not only for the specialists in system engineering. With 3D Experience, you get all the tools you need to do this easily available in one platform that is online, it's cloud-based, it's web-based, and it gives a full visibility of the entire system design for all stakeholders that are part of the system and vehicle development process. And the bottom line is, by following these best practices and methodologies, moving away from physical prototypes, documents, traditional ways of working, organized typically in silos, you will be able to develop better products in shorter time. That's the main takeaway from today's session. Hope you enjoyed it, and feel free to post any comments or questions that you might have in the chat panel next to the presentation. Thanks a lot for listening. Thanks, Achim.
Yeah, thank you, Johannes.
See you next time.
Yes, bye-bye.